So letter B, when we set up the a squared plus b squared equals c squared, the c must be the hypotenuse. So this has to remain c. 8 and 15 don't really matter where you assign them for a and b. I think probably intuitively a comes before a b, so we'll make the smaller number your a. That is not necessary, however. And then we'll make of those two the bigger number the b, so that'll be our 15. All right, and then we just solve this. So you're going to get 64 plus 225. Doesn't look promising, right? Those are pretty big numbers, but when we add those, do this here, we're going to get c squared to equal, when we add those up, 289. Do your square root. While you will initially get a positive and a negative square root of 289, it doesn't make any sense if we're talking lengths of triangles to include the negative. But 289 is a nice perfect square of what? 17. So that side is 17. Okay. All right, and then the last one. Actually, try that one real quick. A little more weird because you got a radical for an answer, but it's still the Pythagorean theorem. You're still going to substitute accordingly, and then from there, see if we can handle how that's going to play out. Question again?
No, I think
Okay. Just give me a second here. I want people to kind of work their way through this, see if they can figure out what happens with this one. All right. Go ahead, Kim. What did you put for A here? Good. So he used 1 for the A, which would make sense because in this case I labeled this as B. So it makes sense that this is B squared, and then C is what?
Square root of 5 squared.
Good. And then we do root 5 squared. All right. 1 squared is what, Kim?
1
Plus
c squared
equals what?
5.
Good. How did you get that?
Doesn't the exponent like cancel out the square root?
Good.
You're just looking at
So when you do the square root of a number squared, there's a couple routes you could take. You could actually square this, right? What is 5? Yeah, so we could actually, let's cross that dumb thing out. If I did 5 squared, you could actually square that and say that's root 25. And then what is root 25? 5. So that's a perfectly valid thought process. The other thing we understand, hopefully, is that a square, the whole reason, like I give you, when we just did the Pythagorean theorems and you get like an x squared equals 25, the way we get rid of squareds are with square roots. They're inverses of each other. So a square and a square root together basically just cancel each other out, right? So wouldn't these just cancel, and whatever numbers underneath the radical ends up being what we would end up with, right? So either one of those thought processes are totally fine. That should give you a 5. All right, so then b squared would equal what, Kim?
We subtract the 1, you get 4.
Good. And then b has to equal, good. Take the square root of both sides, and b would equal 2. That's Pythagorean theorem. A little review there. We're going to need to use that with some of the problems now in this mess of a problem that we showed at the beginning. So now go to this beast and then understand what we have. We have four parallel lines. So here's 1, 2, 3, 4. All right. And then we have 3 transversals cutting through those. All right, so we have this line, diagonal line here, the diagonal line right here, and then we have this line right here. I think the angles are probably the easiest, so let's start with those. So let's find angle A. So angle A is up there, and it's probably, of all the questions, the easiest one. So tell me what angle A is. That we should be able to do. All right, few people in here started punching in the calculator very quickly. So Gavin, you were one of those people. What did you just punch in?
146.
Good. And how'd you get that?
I did 180 minus 30.
Good. So we have a straight line right here. So a straight angle has 180 degrees total. We had 34 of those degrees accounted for right here. So Gavin just did 180, subtract away the 34. That leaves us with 146 degrees left over for angle A. So angle A, 146 degrees. Next, we're just going to go right down the angle side. First, find this angle because there's a lot going on here. So find angle B to C to D. Then, take a minute, think on this, see if we can figure out what it is. I'm going to draw something in a moment, and as soon as I do it, everyone's going to be like, oh, yeah, that's pretty easy. Let's see if you can see that first before I show you. I'll highlight the angle. It's this angle up here, ECD. Okay, before I draw in my hint, because once I draw this hint in, I think everyone's going to get it. Anybody think they know the degree measure of this one? Everybody's blank here. Anybody at home? Okay, then here's your big hint. All right, now tell me what that blue angle is. So now find that. And I'll give you another 30 seconds because now we're all going to get it right. All right, this time when I drew that in here, now we had a bunch of people grab their calculators because then I think we understood sort of what needed to happen. So Jenna, you grabbed your calculator quickly. What did you plug in?
180 minus 53 minus 90.
Good. She did 180 minus 53 minus 90. And where did all that come from? Like, why did you do that?
On the left corner and then 90 degrees.
Good. And what did I highlight here? This is a what? Good. And in a triangle, there's 180 degrees always. We had 53 degrees accounted for right here. This must also be a 90-degree angle because this is 90. So then she took 180, subtracted away this angle, subtracted this angle away, and what did you get? 37. And then we know this is a 37-degree angle. Okay? So that is BCD. It gets hard when all these things are going on, so we want to look big picture things and try to find the stuff that we've learned. There's nothing new here. We're just employing different strategies of all the things that we've talked about here in these last couple geometry modules. So, number 3, find angle AEB. Try to write this a little better here. And see if you can find that one. Okay, let me find it too. Where is it? Okay, a lot going on here. as you're wrapping up, if you're getting it, the answer is 93. So if you're finishing, you're wrapping up, and you have a thought process in your head, if you get a 93, then good, you did that right. All right, and we'll talk about here in a minute, but just so you know if you're on the right track. Good question, right, Ahmed? Anybody get 93? Gavin, what'd you do, Gavin?
I did for the triangle CBD. I added all those together and I found the corner for B. And then I knew that it was the other side too. And I added 34 and.
Yeah, stop right there real quick. So what he looked at this little yellow triangle right here. This is a 37 degrees. Here are parallel lines. So if I just look at this line here and this parallel line down here, remember the whole corresponding angles idea? Isn't this angle here, upper left-hand corner between these two parallel lines and this transversal? Isn't this also the left-hand corner? So upper left-hand corner here, upper left-hand corner here. So he knew that this was a 90-degree angle. So we did the same thing that we just talked about. He did 180 minus the 90 minus the 37. And then that told us that this little guy was what, Gavin? 53 degrees. All right, so that's what he was saying. Then he added something here in a second. But first, hopefully we understand that now that we see that. What was your next thing that you thought?
I added 53 and 34 and subtracted that from 180.
Before that?
I moved it to B.
Do you know what these are called? Can you use fancy math words? Angles that are directly across from each other. Can anybody help Gavin what those are called? Yep, like this guy, this guy. Yeah, those are vertical angles, right? So if this angle that he found to be 53, this angle here must also be 53. Now we're inside of this triangle here. Come on, yellow. So now we're inside of this triangle. Don't we know two of those three angles? So we do our 180 minus 34. That's why he said 180 minus 34 minus the 53. Whatever's left over has got to be this angle that we are looking for. All right, and then that's where he got the 93 degrees from. All right. So a lot of thinking, right? I just walked around. I just had to proctor the SAT on Tuesday, and those are the types of questions you'll see where they make you think a little bit. All right. Some of them are nice, but some of them are definitely ones that make you think. All right, so put 93 for that. And then there's two more. All right, EHG. So let's first find it. EHG. Where is she? I can't find E. Oh, because I wrote over it. Okay. So EHG. Let me get rid of the shadings. EHG is this angle here. This one I'm going to cross my fingers, more people will get. Let me give you the hint right away so we can speed it up. We can feel good about ourselves. So do a little thicker line for this. So this line is parallel to this line. All right. And then here's your big hint. We have a transversal that's intersecting those two lines. Now, hopefully we can all get that. So what we're doing in this section more than anything, we're graduating from just giving you those two lines with that red transversal cutting through it, where it's very obvious, to embedding this in a bigger graph of things. Because my guess, if this question was on your quiz with just the two black lines and the red line, we would all get this. All right, but it's a little bit harder when you've got all these other things going on. So, what is this? Anybody? This one, no calculator is needed. Cam? Not quite. You did supplementary. So aren't these inside? So remember, we're inside of the parallel lines. It is 34 because we're inside. Good. And they're on opposite sides of the transversal. These are alternate interior angles. Alternate interior angles are congruent. So that has to be 34 degrees. Okay. Now, as soon as I erase all these, it's not as obvious. But that's why we kind of, the first one was finding a triangle in there. Second one is realizing those are parallel lines with alternate interior angles. So that's 34. And last angle, measure of angle KHL. Is it KHL? There, yep, thank you. Oh, no, it's harder than it looks. KHL. Where's this? Okay. All right, so I'm going to shade in that line. So the dark black line, because we're looking for this yellow angle right here, K to H to L. Don't tell me it's 30. This is not vertical. 34 and this angle would be vertical. Okay, so they're not vertical angles. And then there's a couple different routes we could take here. I'm going to go up to this one. And then let me draw in our transversal. Yeah. Here. Actually, you know what? That's not the one. See, that's what I mean by, that's why I keyed this up. There's a lot of different routes to take. Let me actually shade in the bottom one. I think this will be more obvious. So let me do this guy. So now, tell me what this angle is here first. And then once you write that angle in, I think you're all gonna, if you don't know it yet, grab calculators and you're gonna be able to figure out the one that we're ultimately looking for. Got to be 34, right? Because isn't this an alternate interior angle with this guy here? This guy here, those are alternate interior angles. So this is a 34 degree angle. So can't we, and this is 90 because that's got the little square there. So in that triangle, 90, 34, subtract all of those. What do we get? Good. Is that what you had? Is that what you had?
Yeah.
Good. That should be 56 degrees. Okay. All right. So some good thinking there. All right. Now let's go to the side. Let's try to get a few of these done here. Find the length of GI. So find GI. Yeah, let me clear out all this stuff. All right, so GI is here. We want to find that length. Here's your hint. We have a right triangle, correct? What do we know this length here has to be? Not marked, but what would we know that's got to be? Gavin? And why do you know that, Gavin? Yeah, see this right here? This is 12, so these two lengths would have to be the same. This is why we did the Pythagorean theorem at the beginning of class, because now if this is a right triangle, and I know this is 9 and this is 12, then I can go ahead and do 9 squared plus 12 squared would equal that hypotenuse squared. So I'm going to do, we'll do it work right here so we know where we got it. 9 squared plus 12 squared is going to equal that length of GI squared. If you want to put C squared, that's totally fine also. But it's a right triangle. We go through this. this should work out nicely. So you're going to get an 81 plus a 144 equals the length of GI squared. Add those, you should get 225. Quit spinning. There we go. Good. And then that's a nice perfect square. So when you do the square root of everything, GI, when we do our square roots, should be 15. And then we know that length. So then mark that in. All right, then real quick. Now knowing this, find FH. So find FH. Get rid of all of this. Don't clog it up too much. This is what, as a hint, this is what we quizzed on yesterday. So we're looking for this segment right here. So notice, do it real quick, it's probably our last one anyway, see if we can kind of see what I'm talking about. We did this on our quiz yesterday, and we probably all got this question right. But now it's just involved with a whole lot of other stuff on a graph. All right, I'll highlight everything else, and I think once you see it highlighted, you're going to think, yes, that actually is easy under normal circumstances. So I'm going to take FH in 10, and then in blue, change for me. Don't we then have this guy compared to that guy? And then aren't we able to set up a quick little proportion? 10 is to 15. As I'll call this FH, you call it X, whatever. X is to 12. All right, so 10 is to 15. You might want to write it on where you're doing it. I'm going to do it up here so I don't have to move the screen. So the 10 is compared to 15. As this FH, I'll call this X, is compared to that 12. And then it's a quick little proportion that we all get right yesterday. All right, we get 8 for that. All right. Okay, so nothing really new. The next couple of problems, actually, if we go to the next page, these are actually then nice. These are when they're not all embedded with a whole bunch of problems in one. So we don't even necessarily need to spend a whole lot of time with these anyway. This is largely what your quiz is on. But your homework, so you are going to get some homework tonight. You're going to do these, some Pythagorean theorem review. And then this is the one I really kind of want to see how we do, where there's a bunch of stuff in one, and we're going to have to kind of pick out what these values are. All right, so you're going to do 1 through 10, or actually 1 through 13 there. Just the next 2 pages. If you have any questions, we can certainly talk about some of those tomorrow if you do have a hard time with them. But you're going to do 113 for tomorrow night. Okay? All right, if you're at home, you guys can check out. We'll see you tomorrow. If there's anything I need to look at on a quiz too, let me know if you think I messed something up. All right, we'll see you guys. Have a good day. See you, Kevin. Thank you, you too.
Have a good
See you, girls. Thank you, you too.